Okay, so I have a couple of announcements. First of all, I'll get to that in a sec. I was going to tell you what the code is, but I will put it up here so that when I share my screen, it'll be ready. Okay, so a couple things. People are working on problem set 1, and we did run into an issue with that because it took a while, and thank you, Jason and Ben, for helping me figure it out. But it turns out that either some versions of Excel are not compatible with ArcGIS, or if you don't, the same thing will occur, same problem will occur if you have Excel, if you don't have Excel and haven't installed a certain little program. So I sent an email. If you haven't gotten the email yet, and you're having trouble getting an Excel file into ArcMap, make sure to check out that email, because I posted on a solution, and feel free to email me and chat or whatever, Facebook, anything, if you get stuck. How's your grandmother?
She's good. Just as crazy as I gotta love her. She's funny.
So do look for that if you're having trouble getting Excel to talk to ArcGIS. The problem, I was able to reproduce the problem on my own computer, but it wasn't a problem on the lab computer. The lab computers were working, which is why I wasn't aware of it. And it's a known issue. And then, and problem set 1 is due, what is it, next Friday or something? So you have one more week. I try to have it like a day after we meet, so you've got it going. But if you haven't posted, there's a discussion, right? And that was due like already. All my classes are blending together. Yes. So there's your discussion. And that was due, I think, yesterday. That's correct. No, tomorrow. Yeah, tomorrow. Okay. Yeah. I'm like, wait a minute, all these people haven't posted yet. So if you haven't posted yet, you want to hop on that. You will be harassed by Google Classroom. I make myself a little fake student, so I see how you're harassed. And so I got a notice today telling me that that was due today or tomorrow. So that's handy. So make sure you hop on there and do that. And then, so next week when we meet, I will assign problem set 2, but we're going to start the stuff you need to know tonight to do problem set 2, and it's really fun. So let's get to that unless you guys have any questions, those of you who are on the call. Okay. And let's see, Zach, are you at home or are you in Orono at the lab there? You're at home, great. Good to know. Question?
Oh, no, my computer was stupid.
Oh, they do that.
I keep putting in the right password 3 times, and it's like, oh, okay, you did put it in right, and then it opened up out of nowhere.
Yeah, the computers here take forever to log in. Yeah. That's that kind of a problem. All right, so let's. Hi, Ethan.
Hello.
I've got it so you guys can hear me and I can hear you, which is a good improvement. So I'm going to do this, present to everybody, and make sure that it's being recorded. And the attendance code in here, Ethan, I'll mute you temporarily. You can always unmute yourself if you need to talk. And the code is 5414, the attendance code. Oh, I think I sent it by email already, didn't I? Okay. Yeah. I'll post it so that you can do it later. But oh, there's Grace. Oh, good. So she's on. Yeah. We hear that. We don't want you here, Grace, but we love you still. And we can hear you. And
Okay.
yeah. So I'll mute you now. If you want to talk to us, though, if you have a question or something, just unmute yourself.
Okay, sounds good.
Yeah. All right. So, okay, so the attendance code is 5414. And I'll get rid of that. And so what we're going to do today, you're going to need, you probably already have it, but I just want to make sure that you have it, and I'll demonstrate downloading it again. But if you go to this week's page, there's another handy dandy link to the practice data folder. And there are two things you need in the practice data folder. That is hydro.zip and census.zip. You need those two files. So I'm going to download each one to my GIS 230 folder. And I know you've downloaded them before, so this is going to be PS2 practice. There's the census data folder. Anyway, but you need both hydro and census, and then you need to unzip them. You're also going to want ArcGIS open. Whenever you start with your legs, I'm like, ah.
Sorry.
Yeah.
And I don't know if you noticed, but the whole screen shakes.
I'm sorry. I'll try not to.
She was, I do the same thing. I'm a wiggle worm, wicked wiggle worm. Okay, so I'm going to get a new, let's see, I got to save this so that I have it when I go to teach my other class next week. So this is parcel dig. It's good. So I'm going to get a blank map in ArcMap. I'm going to unzip these two folders. I'm not going to go over how to do it because hopefully by now you can unzip folders. You having trouble there, Aaron?
No, it's just been really slow.
ArcGIS takes a zillion years to open.
Yeah.
But you downloaded and all that and unzipped?
That was a while ago.
Yeah, I'm just making sure.
Yeah, that's awesome.
Okay. So once you have that, going to ArcGIS, I'm going to find my folder. GIS 230.
I think you need more powerful computers in here.
Yes, we do. We absolutely do.
Probably a little hefty for it.
We absolutely do. There we go. GIS2 practice. And we're going to need counties. We're going to need states. And we're going to need rivers. Just those three layers. So counties, states, and rivers. And we absolutely do need more powerful computers in here. This is their last hurrah, their last year.
You think with the GIS lab, you could at least have fairly up to date.
Well, yeah, we get new ones every 3 years. So since I've been here, this is the third round of them. So it's just that you're catching them in the third year.
Counties, states, and rivers?
Counties, states, and rivers, yep. And that's fine, Ethan. You have that choice, absolutely. So if you don't want to watch it live, that's totally cool.
Is there a way I can get it so the counties or the states not complete?
Yep.
I don't know.
Yep.
But
so that's a good question. So right now the states are obscuring the counties, right? I can turn them off, but how can I be able to see the counties underneath the states? What can I do?
You put them on the same layer, I suppose, or I don't know, because it's not like states are. I mean, you can kind of see the state lines with counties, but you have to really know what you're looking for.
So what is the problem with the states layer? What is it doing?
It's cold. So
It's-
to make it.
You have to make it hollow, yeah. And fortunately, that's super easy. So if you just click on the little patch, mine happens to be a blue patch. If you click on that and change the fill color to no color, and I'm gonna widen the outline a little bit, maybe 1.5. And you can even make it some sort of fun color. White is kind of fun.
Oh, wow, that is.
Or
No,
maybe
it's
gray.
like- Two, way too.
Yep, 2 is kind of big. I'm gonna zoom. So, and I guess I do want these to be a little darker. So fiddle around, make things the way you want them so you can see them well enough. I don't like that green. I'm gonna change that green. I want a lighter green. I'm gonna change the whole thing.
Oh, wow. Okay, red and blue does not go. Don't do that.
So what I'm gonna do now is we're going to do some spatial analysis, some of your first actual analysis. And we're going to use something called queries. But when we do queries, sometimes we're going to be measuring by distance. And there's a problem with our map that has to do with distance. You got some guesses? There's a weird, why does our map look weird? How is it weird and why?
That's not really how the United States are set.
Yeah, it doesn't look how the United States are shaped. And Zach's got it, it's the projection, right? So we need a better projection for this map. This projection is not gonna work. So, and the reason is that actually throughout the entire map, the whole thing, distance is greatly distorted. So even in this area down here where we have less
It's really stretched.
distortion, it's really stretched up here. But even here, it's not going to measure distance accurately. So before we do this, we need to make it so that we can measure distance. And you'll see in problem set 2, when I post it, you'll see that there'll be a reminder there. And so what you're going to do, the assignment will be to do a similar analysis to the one that we're doing in class today. And if you don't change the projection at the beginning, all of your answers will be wrong. Yeah. So when you go back to this video, you might want to go back all the way to the beginning to the part where I say all the answers will be wrong if you don't change the projection. So let's change the projection. And again, we haven't talked about projections yet. We'll be doing that soon, actually. So hi, Liz. So we're gonna change the projection. That's a characteristic of the data frame. That's what this layers thing means. And so we're going to open the properties window for the layers data frame. And now if we scroll all the way up, the default, and that's because the data that we used has this projection assigned or has no projection assigned. A geographic coordinate system means there's no projection, it's unprojected. We want to project it. So we're going to use a projected coordinate system. I'm going to expand that. And I want continental. We're just going to use the continental United States. In this case, only contiguous US. Oh, we lost Liz. And then, of course, we want North America. And we want USA contiguous, and you can use either one of these. They won't be appreciably different. I'll use the non-USGS one, and I'll click OK. So USA contiguous Albers equal area. Oh, I forgot. Sorry, wrong one. My bad. USA contiguous equidistant conic. So there's a reason that Albers equal area does accuracy for area. We're interested in accuracy for distance. So equidistant conic. Sorry. The conformal one is shape. We don't care about that. Okay, really. Now we're ready. We'll click OK and say yes when it says, are you sure? That looks much better. That looks like the world, like the US looks on the world, right? When I look at the globe, that's more what it looks like. And so it's decreased the distortion of distance. And no projection gets it perfect. It's not possible to squash a map onto a flat surface and have it be perfect, but this is as good as it's going to get for our purposes. So what we're going to be interested in doing is looking at the relationship between census data and the locations of rivers in our map. So let's look at the rivers first of all. Open the attribute table for the rivers layer. So in the rivers layer, I've got just a few, columns here, fields. There's the name of the river itself. Then there are systems, and then there are miles. So the number of miles in that segment of river. It's only the major rivers, of course, but it is the major rivers. So notice that so if I right click on the word system and choose sort ascending, and I scroll down, some rivers aren't part of a system, they're just all by themselves, right? But I can see there's the Colorado system, there's the Columbia system, Mississippi, and so on. And there's several rivers in each system, right? So the Columbia River system has a bunch of rivers in it. And that's what we're gonna look at, is the Columbia River system. So I'm gonna clear my selected features and go down here. So, what we're gonna do is a series of selections, and there's two kinds of selection tools. And believe it or not, they're in the selection menu. So if I click this pull down right here, there's select by attributes and select by location. And we're going to start off by asking it to select by attributes. So I'm going to click that and open it. And for rivers, let's start out by asking for a river by name. So what happens is, this is my list of fields, right? This is my query box down here. And these are tools to help me build a query. And a query is a question that essentially you ask of the data. So I'm going to search for a certain name. So I'll click name, and I'll double click it, and it will appear in the query box down there. Equals, because I want a name, a specific name, but I'm not sure how to spell Willamette, right? Is the river I'm looking for. I'm not sure how to spell it. Turns out I can ask ArcGIS to list all my rivers. So I'm going to click name up here, make sure that's selected, and I'm going to click this Get Unique Values button down here. And I can scroll. In fact, there's a lot of rivers, so I'm going to type Will. I'm pretty sure it starts with Will. And sure enough, there it is, Willamette. So now I can double click it, and it appears in my box. So my query, this is my query, name equals Willamette. like that. And notice that I didn't have to type it. Typing a query is a real pain in the neck because you're like, if you're anything like me and you have bad eyesight and everything, you're going to get it wrong all the time. I can never remember which gets double quotes and which gets single quotes. So typing code just isn't that much fun. So that's how you create a simple query, and I'll click OK. We'll dismiss the box and it will select it. I can go back to the selection menu and say zoom to selected features, and there's the Willamette River. I still live near it. I lived in the Willamette Basin. So that's great. Now, what if we want to select, let's select all of the counties that have, so I'm going to go to selection, select by attributes again. And this time I'm going to query a layer. I want counties. And this time I want to query all the counties in the US that have a population density under 50 people per square mile. Let's try that. So population density is going to be POP 2010. So that's the field I'm going to use. Double click. And now unique values, that's not going to help me. There's going to be a zillion of those, right? So what I want instead is, what did I say, less than or equal to? Less than or equal to 50, right? So population per square mile in 2010, less than or equal to, that's this button right here. Right. In fact, if you had 5 spaces, like I can put spaces, it won't matter. It ignores spaces. It looks prettier if you have a space, but it doesn't need a space. So again, there's my query. Put that over here. Oops. There's my query, like that. Okay, and so once you do that, you click OK. And look, that's actually quite a lot. How about we find out which ones have less than 10 per square mile? So if I go to selection, select by attributes, my query is still there. I can just change that to 10. And click OK. Washington County is still among them.
Worstic is more.
Yep.
Funny.
It is funny. Let's do 5. Do 5. That reduces it. What is that? Piscataquis County, where Mount Katahdin is? Penobscot County.
Not a rustic at less, because the entire left side of a rustic is all paper land.
That's true.
Surprising.
I'm going to turn my states off and get, there we go. It is Piscataquis, which is not surprising because there's very little going on in Piscataquis County. You can see pretty much all of Alaska except for that's probably Juneau right there.
That probably is 10.
And now let's do 1. Let's see if there are any that have 1 person per square mile or less. And there are some. They're all west. Okay, I'm going to do 0.5.
Half a person.
Yeah,
Very thin.
that's very thin. And there are still a couple. I can see down here there are 33 counties. When I run the query, I can see that there are 33 counties. You can also open the attribute table. Oh, 32 counties, I guess it is. 32 counties.
There's a county in Texas that has less than equal to 0.1.
Ooh, wow.
And there's another one in, oh no, that's the river.
So in these 32 counties, watch what I can do. So I open the attribute table and then I click this button over here where I'm showing only the selected records. And then here's the population in 2010. I'm going to right click on that and choose statistics. So the total, the sum, there's of all those 33 counties, there are 127,000 people living in them.
Well,
So, and some of them are really big counties, right? So I'd expect them to be really huge counties. Yeah, square miles, here we go. So if I right click on there and choose statistics on the header there, the sum is 646,562 square miles. That's a lot of area for only 127,000 people. So I'm going to go ahead and clear my selected features, and we're going to start in our analysis now. The clear a selected features button is right next to the select features button. So now we're going to do an analysis looking at the Columbia River. For the assignment that I'm going to give you for problem set 2, you're going to look at the Mississippi River. So for this, for the purposes of this exercise, we need to first select the Columbia River system. So I'm going to go to selection. I'm going to go select by attributes. I got to change my target layer to rivers. I'm creating a new selection. And which field do I want? Name, system, miles, object ID.
would be this, Columbia River.
So the Columbia River system.
Okay, well,
System. Yep. So double click system. I'll choose equals, and then I'll hit that get unique values. And there's the Columbia, and I'll double click that. Notice that it's really important if you have multiple features that have the same information, they need to be identical, right? We were talking about that last week when, you know, Columbia space is not the same thing as Columbia with no space. Okay, so I'll click OK. And that has selected those rivers. So I'm going to zoom to my selected features. There they are. Maybe I'll zoom out a little bit. And so the Columbia River system is pretty vast. It's a big chunk of the West, isn't it? You can turn this on and see that it runs through, it forms the boundary between much of the boundary between Washington and Oregon. And it goes all the way up into the Snake River. I believe this is the Snake. Yes, it is. And that's the Columbia River going up there. That's whole Snake, Clark, and Flathead. So it's a big system. These are just the major tribs to the system. So, so such a large river must be kind of important. All right, and the Willamette, the one that I searched for earlier. So I'm wondering how many counties we have within 100 miles of any part of the Columbia River system. And so there's a tool under selection. Do you see it? Yeah, select by location. Good. A tool under select by location. I'm going to select that tool. And this works like, you can read it sort of like a sentence. So select features from, and I'm going to select counties. The source layer is what we're measuring from. That's the rivers. And notice I have the choice of using the selected features. That's what I want. I don't want it to select from all rivers. So if it selects half the country, you know, you forgot to click that check marks right there. So use selected features. And where it says intersect the source layer, we don't want just the ones that it touches. We want the ones that are within a distance of 100 miles. So I'm going to choose are within a distance. I'm going to change the units here to miles.
Are within a distance of the source layer?
Of the source layer, yep. And I'm going to change the number to 100. We don't have 3D data, so we're not using the 3D version. So once you have it looking like this, you can click OK and it will dismiss the box, and all of a sudden you will have this handy dandy set of counties. Now, what if we want to know about some things about those counties? Where would we look? Yeah, so we'll open the attributes table for the counties layer. There's 158 counties, quite a few, really. And remember, we can use these buttons to click back and forth. You don't have to, it will, when you do statistics on a field, it will show you only the selected features anyway. But it's handy. Oh, I forgot to do something with the rivers. We'll go back in a minute. So how would I find out the population in 2010 of all of the selected counties? What's a good way to do that? Population in 2010 of all those selected counties.
Into statistics.
Yes, so I can right click on the field, the column Pop 2010, bless you, and choose statistics. Right click on the field header and choose statistics. And there it is, the sum. And it's pretty large. There's what is it? 13, 1, 2, 3. There's 13,194,000 people living within the counties within 100 miles of the Columbia River system.
You run oh, so you click on statistics.
Yep.
You right click on.
Right click on, yep. And notice up here I can change. So if I want to know crop acres, this is in 2007, right? How many crop acres? There's 25 million acres of cropland in those counties. They used to have mobile homes in this data set, but the most recent doesn't have it. It's kind of a bummer. So people age 65 and up. There are 1.3 million people, right? And so on. So now let's go back to the population 2010. That's the total number of people living in this county. I'm going to copy that. And I'm going to paste it into my calculator. I've got a calculator open already here. Clear. There it is. So I'm going to paste that in my calculator. I want to know what percentage of people, of US residents, live in those counties. What would I need to do?
Divided by the amount of counties. Or,
By the total population of the US. Yep. Now,
oh, okay, I misunderstood the question.
Yeah, so if I want to divide it by the total population of the US, I need to clear my selected features from my counties. So I can click this button, but I'll have to reselect the rivers again, which is a good learning experience. But I can right click on the word counties and choose selection, and I can just clear these selected features. So that leaves the Columbia River still selected. And now I've got nothing selected in my counties. I can go back to looking at my columns here, and I can right click and choose statistics on all of them. So there's the sum. So in 2010, it was 311 million. So I'll copy that.
Where was clear selected features in there? I right clicked on counties.
Right click on counties, and it's selection, clear selected features.
Oh, okay.
Yep. And so I'm going to divide by, and then I'll paste that new number in, equals. So 0.042, so times 100, will give me the percentage. So 4.24% of all people in the US live in this region. It's not very much, really, considering it's a big chunk of the country. So now I have a little challenge question for you. See if you can determine the percentage of all, let's see, the percentage of all, they don't have, oh, yes, they do. AMER-S, that's American Indian Eskimo. So see if you can determine the percentage of all American Indian or Eskimo people in the United States that are living in counties within 100 miles of the Columbia River system. Want me to write that down?
Yeah.
Okay. Yep, no, that's all right. No worries. So the question is, what percentage of all Native American, and that's
Within 100 miles.
yep, that's this AMER-ES and Mary _ ES. That's the field. Are living in counties within 100 miles of the Columbia River system. To see if you can answer that question. So I'll give you a minute to do it. I'll suck on some water here. And all the fires are out. Did you do it?
Yep.
Awesome. All right, so let me do it. See if I can do it and see if we get the same answer. So I've got my Columbia River system selected. And so I now need to do selection, select by location. It's going to be actually the same selection that I did before. Select features from counties and the source layers rivers. Use selected features are within a distance of 100 miles. So I'll click OK. And so those are the selected counties. And I should have gotten the total number before I selected, but I forgot. So I'll get that statistics for that AMER-S field. So 192,470, and I'll put that in my calculator. Then I will clear the features that are selected just in the counties layer and go back to that same field and determine the total, the sum, 2.4 million, no, yeah, 2.4 million, so copy that and divide by and paste equals, and then multiply by 100, and that gives me the percentage. So 7.77% of Native Americans, self-described Native Americans live in that region. Okay. And so one more little, see, I'm trying to think of fun things for you to do. Well, maybe yeah, what about Same question, but what about housing units? What percentage of all American housing, or yeah, what percentage of all American housing units, oh, and Zach got it too, are in the region?
Still with Columbia.
Yep. So in this case, oops, there. So the question is, what percentage of all housing units, that's HSE UNITS, HSE UNITS, are in counties within 100 miles?
That should be the same attribute table. Right?
It will be the same attribute table. Yep. So one thing while you're working on this, I just want to note that this analysis doesn't tell us that those people themselves live within 100 miles, does it?
Or just what buildings are.
Or where, so presumably they live inside the counties, but some counties may have part within 100 miles and another part outside 100 miles. Also, the watershed, right? This doesn't give us the watershed. Zach's got an answer already. You got an answer? It's HSE units. It's this field right here. I'm going to grab the total number. So that's whatever that is, 115 million. So that's the total housing units. And now I'm going to do the selection. I've got those again, and now I'll do the housing units again. And it's the number. Don't you hate that? I think I just did that too. They're handy in that they're if you just hit the start button, they should be right in that pile. So there's that. I'm going to divide it by this. And multiply it by 100. And it's 4.15. All right, so you now know what you need to do much of problem set 2. I need to refer to my notes and make sure I'm telling you everything you guys need to know. Give me a sec here. All right. Have I talked to you guys about scale yet? Did we have a whole like schlemiel about scale? I don't think so. Okay, that's good. So this is some basic. You'll do a bunch more in the labs. In fact, I think there's some right in that first lab that I assigned for you guys on the online things. And so that is the primary thing that you're going to need to do problem set 2. It's too late today to start projections and coordinate systems, which is what we're going to start next week. But we've already done joins. So what I'm going to do is talk with you guys about scale. And I'm going to throw in some fun stuff about where to find other kinds of data. So we can leave our map the way it is right now. I'm going to clear my selected features, and I'm going to zoom over to Maine, scooching right over to Maine. And let's see, I think I've got, we're not exactly supposed to do this yet, but I think we'll do it.
Your own rules, huh?
I'm playing by my own rules. Woohoo! Yeah, okay, we'll do this. All right. Woohoo! Thursdays are always so much fun. Okay, so now we're going to switch gears a little bit, and this will give us a little bit of an introduction. There's a link that you're going to want to have. I don't know if I've shown you the main GIS data catalog yet. Okay. And if I had planned this, I would have posted it on our website, but I will right now. So, Maine, we're super lucky. So I'm going to go Maine GIS data catalog. We're super lucky because we have actually a really good Office of GIS, a Maine Office of GIS in the state. We go back to week 4 and refresh. Hopefully, it's been grumpy about updating. I'm not impressed. I'm going to give it a piece of my mind. There we go. So underneath the link to the practice data is a link to the main GIS data catalog, and that looks like this. It has this terrifying warning at the top that it's going to disappear. It's been there for like 2 years, so and it may be imminent. I don't know. And in fact, what they say you can go to this other place. Very few of the data sets are there, but any data sets that are now supposed to be gotten from that other site, they're linked from this page anyway. So you can just, for now, just ignore that. Someday I'll open this. I say that now.
What's tomorrow?
Well, you know, last semester, they're like, oh, all right, we're going to put a swipe card in the lab. Better get your students ready. And it's like the week before finals, right? And so I'm like, okay. And I made all my students during the last week of classes go get new cards if they didn't have them. Did they put in the swipe cards? No, not until the beginning of this semester. Yeah, they can't do it anyway. Don't get me started. Just don't get me started. So anyway, this may disappear at some point, but I wanted to point out some really important things. We'll do a lot more with this website right now. Not right now, later. So it's you're going to reference map, and that'll be problem set. I think it's going to be 3 is where it's looking like. So you're going to make a reference map, and you're going to need a bunch of data from this site. But for right now, we're just going to get a couple things. So notice that there are all these little icons, and this is a little key to the icons. A shapefile is it's probably the most common type of GIS layer. And it's a vector layer, meaning it's point, line, or polygon. Well, I should go over that with you too. But anyway, we'll get to that. So that's a shapefile. Google Earth, they have some layers that work in Google Earth. This is a raster layer, like an aerial photograph is a raster. Other things you don't really need to think about. And then tiles are things that you can get in chunks, right? So they cover the whole state, but you only want one chunk. Usually they're big things. So if we scroll down, the first The first block here is administrative and political boundaries. And I want you to notice we've got this CNTY24 county boundaries layer. And there, I'm going to have you download it. You can tell this link doesn't look like a shapefile. It's this data download link that's going to bring us to their fancy new website where it's harder to download the data. Yeah, it's such a delight. Anyway, and so there it is, main boundaries county polygon. I'm going to click that and it opens its own page. There's a download button over here. Let me zoom in a little bit so you can see it. So there's a download button. Oh, it disappears when, oh, there it is. Download button, and click that. And what we want is a shapefile. I'm not sure what you get with a spreadsheet. That would not be that useful. And I'm going to go ahead and put it, I'll put it in my PS2 practice. That's good enough for now. And then, of course, it's a zip file, so I'm going to need to go to it and unzip. 7-zip, extract here. You should know the drill by now, and it gives me this main boundaries polygon. And all of these separate files, and there's 6 of them, those comprise one shapefile layer. Once you have that, go ahead and find it. Remember, you might need to refresh your folder in the catalog and drag it into your map. There it is, main boundaries county polygon. I'll pull it in. I'm going to change its color so it's not the same color. I'll make it beige.
You go to 7-zip and extract files, right?
Yep. I usually just do extract here if I put it in a folder where I want to keep it. Once you do that, I want you to take a minute and zoom in really close to the coast of Maine. And then turn off the Maine counties layer that you just downloaded and look at the coast of Maine as it appears in your counties layer. There's something funny going on here. And they didn't look so bad. So when we were looking at the counties, when we were looking at them like this, that didn't seem bad. But yikes, when I zoom in over here, that's not good. So these main counties here, those look a lot better, don't they? Zoomed in like this. But what if I zoom out? What's going on here? That makes Maine look really bad now when I'm zoomed out like this. Why? They do. I can get rid of the water. So for instance, I'm going to go to the properties for that layer. And I know all about the symbology tab here. I'm going to go to categories. And in fact, there's a land category. So I'm going to change this to land. So unique values, land. And I'm going to click add values. And I just want land, yes. So I'm going to click that and click OK. Land, yes. And I'm going to turn off all other values. So it's just going to show me land. Oh man, that color is going to be so bad. So I got to choose something else. Sure, red is good. So I got rid of the water. That still looks kind of bad. Why does it look bad until we get zoomed in here? Why does it look better here?
You still have the one underneath it, maybe?
Well, I will. If I turn that off and zoom out, Zach's got it. It's the detail, right? Look, it makes that ugly squiggly line, right? And so what we're looking at is data, two different kinds of data that are made to be viewed at different scales. And often we call them, in fact, people refer to this layer, this county's layer, as the 24K, meaning the 1 to 24,000. So watch this. If I come over here to my scale, my map scale window, one of my choices is 1 to 24,000. That is a common scale. Let's see.
How do you refresh your catalog?
Right click on a folder and choose refresh. Let's see. I zoom to layer. There we go. I guess I'm going to have to zoom in. I can't center on it. There we go. So now I'm going to go to 1 to 24. So it's going to zoom me in. This is 1 to 24,000. And if I look at the weird counties layer at the scale, it doesn't work at all, does it? So this data is made to be viewed around this scale. It's not required. It probably is gonna, yeah, it works very well at 1 to 250, right? But it's meant to be usable at the scale of 1 to 24,000. In fact, if I right click on the layer, so you do this too, right click on the layer and choose data, view item description. It will give me this, which is, oh no, I can't believe it. They don't have metadata in the data. Just shoot me. This is their improved and new thing. Not putting metadata on their data. Yeah. Okay, well, we can go back to the website and we should be able to get metadata here. So see right here where it says view metadata, I can click that. And this is what it's supposed to say. CNT24 contains state and county boundaries for Maine mapped at a 24,000, 1 to 24,000 scale, right? Now let's look at this other data that we've been using. I'll zoom out to the whole country. Right, so there's this data. I can turn Maine off. And I'm going to look at, I'm going to go to data, view item description again. And see what I get there. So this is the counties, generalized, represents the counties of the United States. And there should be dun, 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 use constraints. It should be in here somewhere. It's like 1 to 1 million. Did I just go by it? Here it is. So scale range, 1 to 500,000 to 1 to 5 million. So that's the range at which it's meant to be used. So if I go to 1 to say 3 million, that ought to work okay, and it does. Look at Maine. It should look all right, more or less. Not great, but okay. Yeah, I'm not liking it that much. Here's 5 million. There we go. So data is often referred to as having a scale, and this is what it means. It's not that it can't be viewed in a certain scale, right? Obviously, I was able to turn on the Maine County's polygon layer, you know, when I was zoomed out to practically the whole world, right? Of course, I can view it at this scale, but it's not meant to be viewed at that scale. Okay, now, what is scale anyway? What does scale mean? When I say that this map has a 1 to 24,000 scale, what is that? No idea?
It's the size ratio.
Yeah, good. It's a size ratio. Yeah, so it's referring to a relative size. So the scale of anything really is the ratio of size or area of a map feature to the represented feature in the real world, right? And there are a bunch of different ways that we express scale. So the ratio can be either expressed like this, where we say 1:24, or 24,000 or 2,000 or 200,000 or whatever, or as an actual fraction. When you use this, it's called a representative fraction. Relative fraction. Of course, it never stays on one line, because why? You also can express it using different units, right? So if you say, okay, 1 inch on the map is equal to 2,000 feet on the ground, right? That's another way to express scale. Incidentally, a 1 inch to 2,000 feet is the same as a 1 to 24,000 scale. So if you ever have,
So is that saying like 1 inch, 24,000?
No, nope. So let's see how many inches would be 2,000 feet, since we have a handy dandy calculator right here. So 2,000 feet is how many inches per foot? 12, right?
So it is 24,000. It's 1 inch to 24,000 inches.
Oh, 24,000. Yes. Yes, sorry.
Yeah. Maybe I was a little too quiet.
I didn't hear that part.
Oh.
Yeah, so it's 1 inch to 24,000 inches. Yes. Yep.
I guess I was a little quiet. Sorry.
No, that's all right. And so, so these are important concepts, but one of the hardest concepts is it is a little confusing, because the way map makers talk about scale is different from the way lay people talk about scale, and it makes it pretty confusing. So let me zoom in here to make this a little clearer. So when we talk about a fine scale map, so 1 to 100, let's say, that's a super fine scale map. Let me go over here. I'm going to add a base map. See if I can get to 1 to 100. So that's a super fine scale. Yes, I know. Zoom to that. I'm going to zoom in over here in Southern Washington County. I'm going to turn off these counties because I'm going to keep going. Turn off this. And if I keep going and zoom in, there's 1 to 1,000. See how that does. And then 1 to 100. So that's a super fine scale. Obviously, the map isn't meant to be viewed at that scale. Let me go back to 1 to 1,000. There we go. So when I say that the map has a fine scale, I actually, in cartographic speak, we say that has a large scale. And the reason is that the representative fraction, for instance, 1 over 100, is larger than a coarse scale map. 1 over 1,000,000 is a much, much tinier number, isn't it? Right? And so we say that a 1 to 100 map or a 1 to 2,000 map has a larger scale than a 1 to 1,000,000 map. So that'll come up, it'll drive you crazy. And what I end up doing a lot is using fine scale and coarse scale instead of large scale or small scale, because somebody and I heard somebody do it in a meeting just the other day. Yesterday I was giving a talk and somebody referred to large scale maps. And I knew what they were talking about was, we were talking about problems of scale and the way people think about scale and how you try to communicate it. And they were saying, oh, well, you know, I've gone to a meeting with a large scale map and people couldn't find their houses, right? So she used the wrong term, but of course she doesn't know that she used the wrong term. She just used the term that made sense to her. There we go. So any questions about that?
How do we get a base map?
To get a base map, click this little downy button right there and choose Add Data. All right, I had another thing I wanted to say about scale. No. Nah. It's too late to start something new.
Okay.
I'm not gonna argue.
Yeah, no, I think it's good. So that'll give you enough to chew on for now. You're working on a problem set, and I will assign a new problem set next week. And if you have any trouble with the problem set, one thing I did want to say, by the way, is remember that you can always come in here anytime. And if you're in the Orono group, you can come in here if you happen to be in the region. But also, I have my office hours. I don't know if did I mention this? Huh?
You emailed us.
I did. Okay. So just to reiterate, there's an office hours link. Where is it? There it is on the website. And oh, right. And Olivia Straight is here too. And both of us, yes, and problem set 1 is due next week, although the first part of it, a chunk of it is due tomorrow. So the post on a bad map, is that what it was that I had you guys doing? Yeah, so the post on a bad map is due tomorrow, Zach, and then the rest of it all is due next week. So no problem. So anyway, yeah, so Olivia is going to be doing office hours, and you can reserve office hours with her. And if you'll notice, I'm not available in the evening at all, or in mornings this semester. I have other things going on. And so this is my schedule. So you can see what I have going on. Anyway, so so Olivia has arranged office hours. So there's somebody here, pretty much there's somebody here every day, at least some of the time. And Olivia is physically here whenever I can. I'm physically here for my office hours. And you can reserve a time and talk with us on, and actually, you know what, it just occurred to me, I can reserve a time with Olivia this way, because I got her set up. That's cool. Anyway. And Olivia's awesome. She's been she's been working in the lab. She's taken like 4 or 5 GIS classes and been working for me for 2 years. She knows as much about all of this stuff as I do. So you should be fine in her hands. And she may be more reachable. And so I sent you guys her email address, and you can reserve a time. And we can both do those hangouts. So a hangout just like this, but just between us. So if you can't physically be here, you can share your screen with us so we can see what the problem is and fix it. And it's amazingly effective. And she's really experienced with that too, because she's taken so many classes like this. In fact, her first year internship, this year she had to, yeah, it was this year she had to stay. I can't remember, it's all blending together, but this year she'd stayed. Right, we did the shoreline zoning. Last year she was working on unorganized territories mapping, and she went home in New York. And so we met once or twice a week that way, and it worked out great. So she knows all about it. So use her shamelessly, especially if I'm busy. We've got presidents coming, and they're going to visit both campuses, or potential presidents coming. They're going to visit both campuses, so watch your email for notices about that and participate. I'm on the committee that's selecting them. So I'm going to be super busy next week. And so Olivia is going to be really helpful to you in problem set 1 because my office hours are trimmed back for next week. All right, I'll shut up now. I ended up using up 4 minutes of the extra time I was going to give you. So sorry. Okay, one more class, then I can go.